All right, so we're back looking at an example 3, which is dealing with application. So what it says is Ada has at most 285 beads to make jewelry. A necklace requires 40 beads and a bracelet requires 15 beads. Okay, so there's 3 things that we need to do. Number 1 is write a linear inequality to describe the situation. Then what we're going to do is we're going to graph the solutions, and then lastly we're going to give 2 combinations of necklaces and bracelets that Ada could make. And if you see, we already have a graph here set up for us, which is awesome. So let's get started. So the first thing would be to write that linear inequality. To write a linear inequality, first what we need to do is define our terms. So for A, let's go ahead and it says, okay, so Ada has at most 285 beads to make jewelry. A necklace requires 40 beads and a bracelet requires 15 beads. So what are the 2 things that we're talking about? Well, we're talking about, well, beads, right? But we're talking about making necklaces and making bracelets. But we don't know how many necklaces or how many bracelets we're gonna make. So those are our variables. So we're gonna start off and say let X equal the number of necklaces, and then let Y equal the number of bracelets. Okay, now as we write our inequality, how we're going to do this, this is a type of application where we have a total amount, and that total amount is made up of pieces, right? So our total amount is actually 285, right? So I'm actually just going to put the total over here on this side. And then that 285 is made up of 40 beads per necklace. So that would be 40 times X, the number of necklaces. So 40X plus the other piece would be the amount of beads needed to make a bracelet, which would be 15 beads per bracelet, or 15Y. Okay, so we have a total amount of 285 beads, and that is going to be made up about how many beads I use per necklace and how many beads I use per bracelet. Now we have to figure out, well, what symbol are we going to use? And some of the key words right here is at most. So what that means is at the most we have 285. Okay, so that means that this amount here cannot be over 285. This amount here has to be less than 285, right? Because if this amount was over 285, we don't have any more beads than 285, right? So this amount has to be less than, but then when it says at most 285, that means that it can equal 285. So we get that, so this amount is less than or equal to 285. That is our linear equality. So we have that written down right there. So that's it for A, write the linear inequality to describe the situation. So now we're kind of on to B, which would be graphing the solutions. So to graph it, we kind of have to change up this linear inequality, because to graph it, we need to put this in slope-intercept form, right? So I'm going to write this here. And then we just need to isolate Y and get Y by itself. I'm going to kind of move this up so we have a little bit of space to do that. So I'm going to get rid of this 40 first. And we want to put it into slope-intercept form. Remember, that's Y equals mx plus b. So that means that I'm going to put this x first, and that would be a plus 285. Perfect. Then I got to get Y by itself, so I have to divide everything by 15. Okay. 15 divided by 15 is 1. 1 times Y is just Y. Okay, we have 40 over 15. I'm going to try to reduce this fraction. And so what number goes into both? I would say 5, right? 5 goes into 48 times, and 5 goes into 15 3 times. So that really simplifies into -8/3x. I like my 2 shades of purple there, dark and light. That's kind of nice. All right, and then we need to simplify this right here. 285, does it go into 15? Okay, so if I want to know if 15 goes into 285 equally, I know 15 is pretty much made up of 3 times 5, right? So what that means, if I show that 285 is divisible by 5 and by 3, 3 times 5 is 15, so that means therefore it'd be divisible by 15. So what I know is I know that they both end in a 5, so that means this is divisible by 5. Then if you remember how to tell a number is divisible by 3 is that you add up the digits. So 2 plus 8 is 10, 10 plus 5 is 15, and is 15 divisible by 3? Yes, it is. Therefore, this number is also divisible by 3. So since it's divisible by 3 and it's divisible by 5, we know that 15 evenly goes in there. So I'm just going to have to figure out how many times. I don't really know that. So I'm going to go over here. 285 divided by 15. Does 15 go into 2? No. Does 15 go to 28? Yes, 1 time. And then 8 minus 5 is 3. 2 minus 1 is 1. Then we drop down that 5. How many times does 15 go into 135? I don't know. Maybe, shoot, I'm totally guessing. 9? Does it go in 9 times? Well, if it went in 10 times, it'd be 150, right? 10 times 15 is 150. And that's kind of close, so I think it will go in 9 times. 9 times 5 is 45. Write the 5, carry the 4. 9 times 1 is 9 plus 4 is 13. And boom, there you have it. It goes in 19 times. So 15 goes into 15 once, and 15 goes into 285 19 times, which means we have 19 over 1, or just 19. Perfect. Now we have it in slope-intercept form, so we can graph it. So the first thing I'm going to do is go ahead and write that y-intercept, which is positive 19, which is right here, right? It's like in increments of 2. Nice, nice. And then we're just going to go and graph the slope from there. So y-intercept is 19. And then we're going to go down 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then over 3. So 1, 2, 3. It should be there. That's 19 and that's 11. Yeah, just trying to make sure. So that would be down 1, 2, 3, 4, 5, 6, 7, 8 over 3. 1, 2, 3. Perfect. And we're just going to do the same thing again. Down 8. So if I'm at 11, 11 minus 8 would be 3, which would be right here. And then over 3, 1, 2, 3, which would be right here. Okay, so now I have my points. I can go ahead and graph my line, but I need to know, is this going to be a solid line or a dashed line? And since it's less than or equal to, we know it is going to be a solid line. So we're going to have a beautiful solid line along here. And that represents anything along this line can be a solution. Okay, but graphing is just not the boundary line, right? The first step is solve for y to put it into slope-intercept form. Then the next step is draw the boundary line with either a solid or a dashed line. And then the third is the shading, right? So this is y is less than or equal to. So that means we would shade below the line. And so our solutions are really going to be anything below. So the line is here. So anything in here, and it wouldn't be any negative numbers because we're talking about making bracelets and necklaces, and so that wouldn't really apply here. So really any ordered pairs in this solution would work. Okay, or along the line. So So yeah, okay, so that's it for graphing, right? We put it into slope-intercept form, we did the boundary line, we shaded. Okay, so this represents all of the solutions for this particular application. Now we just need to give 2 combinations of necklaces and bracelets that Ada could make. And it would fit these requirements, right? So, really anything, right? So it could be anything along this line or anything in here. So if we look here, we have 2 right here. This is a solution. It's just a point. So that's a 2, 8. And notice that this is necklaces. So when we defined our terms, X equals the number of necklaces. This is the x-axis, so all of these numbers are talking about the, and I should have described that, I'm sorry. Oh, I'm sorry. The x-axis is talking about the number of necklaces, and the y-axis is talking about the number of bracelets here. And see, we have a title for this, which is jewelry. So when you do your homework assignment, you need to make sure that you label your x-axis and your y-axis, which is going to correspond with whatever your variables are, and then put a title on your graph. So we're doing C. So this is one solution. So one solution is that Ada could make. And this is just so fun because it's basically 2 is X, X is necklaces, right? So it's basically just 2 necklaces, and 8 is the Y, which corresponds with bracelets. And 8 bracelets, okay, which is basically like 2, 8, right? Or what's another solution? You know, really anything, like right here, this is one right here, which is just 5 and 4. Or Ada could make 5 is the X, which is dealing with necklaces, so 5 necklaces. And 4 is dealing with the Y, which is bracelets. So we just say 4 bracelets. Or 5, 4 would be the point. And those are just 2 combinations, but there's a lot of other combinations. Really, anything in here or any of these ordered pairs along this boundary line could also be. There's a ton of solutions with these inequalities. So perfect, perfect. That's it for example 3. But let's go ahead and look at check it out example 3. Okay, and I just want to go ahead and do this one together just so we get comfortable with dealing with applications of linear inequalities. So for check it out example 3, Dirk is going to bring 2 types of olives to the Honor Society induction and can spend no more than $6. Green olives cost $2 per pound, and black olives cost $2.50 per pound, okay? So we have to do 3 things. First, we need to write a linear inequality to describe the situation. Next, we need to graph the solutions, and then give 2 combinations of olives that Dirk could buy. Okay, so the first thing is to write a linear inequation, a linear inequality of this application. So to do that, we have to define our variables. So what two things are we talking about? Well, if you look here, it says Dirk is going to bring 2 types of olives. So that's really the 2 things we're talking about. We're talking about green olives and black olives. So we know what the cost is per pound, but we don't really know how many pounds we're going to take of each. So that is really going to lead us to our, we're going to use that for to define our terms. So for A, what we're going to do is we're going to let X equal the number of pounds of green olives. And it doesn't matter, we could do this one X or we could change it, right? And Y equal the number of pounds of black olives. So whether this is X and this is Y or they are switched around, when you do a problem, it doesn't matter. You just have to call one X and then call the other one Y, okay? If you see here, they talk about green olives first and then they talk about black olives. So to probably keep consistent with the book and like the answer sheet, I would probably say whichever one they list first, make that your X, and whichever one they list second, make that your Y, and you'll probably be consistent with the book. Okay, so we have our variables. Now let's just go ahead and write that linear inequality. So we have Dirk is going to bring 2 types of olives to the Honor Society induction and can spend no more than $6. Okay, so this is another one of those total and pieces, right? So this is the total amount that can be spent. So I'm going to put 6 over here. And then that 6 is made up of 2 parts, the amount spent on green olives and the amount spent on black olives. So it's $2 a pound for green olives, so that's going to be 2 times X, which is 2X, and then black olives are $2.50 per pound, so that's going to be $2.50 times Y, so plus $2.50 times Y. Okay, so we have $6, which is our total, and our total is made up of the amount spent for green olives and the amount spent for black olives. So now we just need to figure out what is the sign that we're going to use. And the key words, do you guys see them in this problem? Dirk is going to bring 2 types of olives to the Honor Society induction and can spend no more than $6. So no more than $6. So that means that this cannot be more than 6. This has to be less than 6. But no more than 6 means that it can be 6. It just can't be more than 6. So that means that it can equal 6. Okay? So basically there is our linear inequality there. And if you look at our graph, you can see that when we define the variables, X is the number of pounds of green olives, the x-axis is here and it's green olives, and Y, the number of pounds of black olives, the y-axis represents the black olives, and then our title is just olive combinations, okay? So just notice how when you define the variables and you set up your graph, the different types of correlations that are there. So whatever the X is, that's going to be the label for the X, and whatever the Y is, that's going to be the label for the y-axis. All right, so let's go ahead and move on to the graphing portion of this problem. So we need to graph the solution. So in order to do that, do you guys remember what we have to do first? It's kind of like a 3-step process. The first thing we have to do is isolate Y and get Y by itself. And it is not by itself right now. And so we are going to have to do some work. Okay. Okay, so we need to get Y by itself. So I'm going to subtract 2x to both sides. That's going to cancel. I'm going to be left with this. And I want to put it into slope-intercept form, so I'm going to put that x portion first. Now I got to get Y by itself. So I'm going to divide both sides by 2.5. 2.50 is the same thing as 2.5. They mean the same thing. I mean, I can put the 0 there if it makes you feel better, but you need to know that they're the same. So 2.5 divided by 2.5 is just going to be Y. So we have Y is less than or equal to, and then we have some simplification that we need to do here. So I'm going to go ahead and kind of do this on the side. All right, what color should I think I'll use orange. Okay, so this is -2. I'm not going to put the negative because I know a negative divided by a positive, my answer is just going to be negative, right? So I just need to go 2 divided by 2.5. So 2 divided by 2.5. 2 divided by 2.5. Okay, I'm going over here on the side. Can you see that? 2 divided by 2.5. And remember, whenever you're dividing by decimals, you have to know that you can never divide by decimals. So we need to make this not a decimal. And if you move it over one place to the right, you have to move this decimal over one place as well, which means there'd be a 0 there. So we're really doing this. 20 divided by 25. Okay, so can 25 go into 20? No, it cannot. So you put a 0 there, decimal goes up. I need to add another 0. So can 25 go into 200? Yes, 25 goes into 100 4 times. That means it will go into 200 8 times. And then we just multiply. 8 times 5 is 40. 8 times 2 is 16 plus 4 is 20. And there we have our answer there. It's 0.8. 0.8x. Okay, then I need to divide this as well. So this is 6 divided by 2.5. So let's go ahead and figure out what that is. Hopefully I have enough room over here. So 6, maybe I should use a different color. Okay. So 6 divided by 2.5. You can never divide by a decimal, so I'm going to make this 25 and make this, move this over, and it's going to be 60. Can 25 go into 60? Yes, it can. It can go in 2 times. 2 times 25 is 50. We subtract, add a 0, drop it down, and then 25 goes into 100 4 times, right? Yes, it does. 4 times. 4 times 25 is 100. No remainder. There we have it. So this is kind of interesting. This isn't super easy to graph, right? Because we have this, well, we have a y-intercept that's not just a whole number, and then we have a slope here that is definitely not a fraction or a whole number either. So we can graph this though. So we're going to go ahead and graph this y-intercept first. Okay, so what we know is it's 2.5. So here's 2 and here's 3. So if I divide this in half, that's going to be where 2.5 is. And then if I divide this into 4 sections, so I mean 5 sections, 1, 2, 3, 4, 5, then 2.4 is where right here is where my y-intercept is, okay? Then I would have to do the slope, which I could do, you know, I can do down 0.8 over 1. I mean, I can do that. But I think another way to graph this might just be to figure out what that x-intercept is, right? Do you remember when we graphed that using the intercepts where we found the y-intercept and then we found the x-intercept and then we just connected the dots? I kind of think that that might be an easier way of doing that. So that's how I'm going to graph this. I'm going to find the x-intercept. Okay, and what do I know about the x-intercept? Well, I know that y is equal to 0, right? So then I am just going to substitute, well, let me write my original inequality here first. Substitute 0 in for y. Oh, I probably should have done it to the original equation. Yeah, let me do it to the original equation up here. So I'm going to just get rid of this. Okay. So yeah, I'm going to write the original equation here. Remember, whenever you do this, you want to use the original equation. Okay. Can you see that? Original equation, right, this equation, not equation, inequality, sorry about that. Okay, then what do we know about the x-intercept? We know that y is equal to 0, so I'm going to put a 0 in there. It actually ends up being really nice when we use the original equation. It's way better than the other version because that ends up being 0, right? So we're really just left with 2x. And divide by 2. And we end up with x is less than or equal to 3. And I really just think that that means that the x-intercept is equal to 3, okay? Which would be right here. Yeah, okay. Okay. So, yes, we're going to say that that x-intercept is right here at 3. That's where it intersects. The, remember, x-intercept is always 3, 0. Okay. Now, if I wanted to check this, I could by doing what this actual slope is. So let's go ahead so you can see a different way to do this. So the slope for this is going to be, the slope is equal to negative 0.8 over 1, right? So that's the change in y over the change in x. So if this is 2.4 minus 0.8, would be, so the y is here. If you go 2.4 minus 0.8, right, what's that give you? That would be 0.6, and that's 1, so 1.6. So that means you would go down to 1.6, which directly in half of this would be here, right? And then you divide this into 1, 2, 3, 4, 5, right? So you would go down to 1.6 and then you would go over 1. So it would be right there. And then from this point, you would go down another 0.8, right? So subtract, if you have 1.6 and then you subtract 0.8 again from this is 1.6, you end up with just 0.8, which would be right here. So this is 5, that's half, 0.5, 6, 7, 8, 9. So that would be 0.8. So you would go down 0.8 and over 1. And then finally, you would go down 0.8 over 1, and there you are at that x-intercept of 3. So that's just kind of, two different ways to do it. But I think the easiest is probably figuring out what that x-intercept is. So then what we have to do is determine, okay, is this going to be, we solved it for y. Is it going to be a solid line or a dashed line? And since it's less than or equal to, we know that it's going to be a solid line. So we're just going to go ahead and connect those dots, and it goes right through. And then we just need to shade, right? So this is y is less than or equal to, so that's going to be everything below that region, which would be everything in here. So this problem was definitely a little bit more complicated to graph. When you do that, you can go ahead and solve for the x-intercept. It's still capable, you can still do it, but it just has to require just a little bit more work, okay? So we wrote our linear inequality, we graphed all of our solutions. So since it includes, our solutions includes everything along this line and really anything in here as well. So then the next thing we have to do is just give two combinations of olives that Dirk could buy. Okay, so I'm just going to go ahead and choose. This one is pretty obvious right here, right? Just 1, 1. So that means that Dirk could buy, this is, that solution is 1, 1. 1 pound of green olives, so 1 pound of green olives, and the Y is 1 pound of black olives. So that's one option, okay? So this is the first option. A second option, and when you look in here, there's really like no other like really obvious pairs. So what I'm going to do is I'm going to just make this. So I know that this right here is at 0.8, right? Because we did those slopes, and this was 0.8. So I know that half of a pound, which would be right here, would be in the solution set. So I'm going to say this is going to be my point where it's 2, and then this is going to be 0.5 for the Y, which also means a half of a pound. So that is also another solution, is that Dirk could, oh, that's not how you spell could at all, could buy, that would be 2 pounds of green olives, right? Because our X is talking about green olives. So 2 pounds of green olives, and that's 0.5 of, which is Y, which is black olives, and a half a pound of black olives. That would be another one. And like really this, there could be a third scenario, which is this right here, which is just 3, 0. That means he buys 3 pounds of green olives and he doesn't buy any black, 0 pounds of black olives. But it says Dirk is going to bring 2 types. So since he's going to bring 2 types, this would mean that he would only bring 1 type, so that wouldn't be a solution. So the solutions they want 2 different types. So really, these are the answers. So perfect. That is it for looking at linear inequality applications. All right, so when you do your homework, make sure that you set it up like this. So define your terms, write your linear inequality. When you graph, solve it for Y. You might be able to graph it just like that. If not, you're gonna have to maybe find an X-intercept. So graph with your Y-intercept and your X-intercept. Determine whether the line's gonna be shaded or dashed, depending on the keywords in the problem, right? And then shade either above or below from there. And then just pick 2 ordered pairs that are solutions and describe it using the, you know, what they're asking. This was asking us about olives, so we're going to talk about green. Label your description with whatever the problem is talking about. All right, that is it for looking at linear inequality application problems.